Good evening. Am I audible?
Yes. Good evening, ma'am. Yes, ma'am, you're audible.
Okay, yeah. So only 4 5 people are there. Should we wait a couple minutes more?
Yeah, ma'am. Maybe you can wait for three, four
What
minutes.
we'll
Then
discuss
we can
today,
start.
ma'am?
So Piyush sir told me that last session you had started week 10, right?
Yes, ma'am.
So week 10, I think the practice assignment was discussed up to question 5.
Yes, ma'am. There were some questions that were left out.
Yeah,
The
so told
first
me
four
to first
questions. Yeah,
cover those. Yeah. So
yeah.
Piyush sir told me to cover the questions from practice assignment uh, question 5, yes. So I'm going to discuss those questions, but before that, let's do a brief summary of the week so that we remember the concepts. Then we'll solve those questions today. Okay, and the activity questions that are left will be done on Monday.
Okay.
Okay. So let's wait for a bit more. So now it's uh, okay. So 4 more minutes. I'll wait. 6:10 p.m. Then we'll start. Okay.
Ma'am, and I have another question. Can we discuss the pseudocodes presented in this week? That would be good.
Which
I
ones?
have some problems with those ones.
Yeah, which pseudocodes?
Yeah, the pseudocodes in week 10. I mean that has to do with the hopping of the hopping of the stations.
From the slides.
Yeah, from the slides.
Yeah, yeah, sure. Okay.
Okay, thank you.
So I think we can start now. So I have the slides from 10.3. That's what you want to discuss first?
Yes, ma'am. Yeah.
Wait, I'll present. One second.
Ma'am, we want to understand the hops concept here.
Okay, let's discuss 10.3. That covers all of it. This is visible to you?
Yes, ma'am.
Yeah, I'll zoom in. Okay, so hops, I hope Piyush sir had mainly discussed it, but we'll just revise this once more because if you don't understand the hops, then none of the questions will make sense. So, first of all, this entire week is based on the trains data set, right? So, there are two types of cards in it. One is your train card, one is your station card, right? So, train data set information about trains and stations we have here. So each train, see, this is the train card, right? In the train card, each train, so for every train we have a separate card, right? So this is the train number 12259. Now what does the card represent? It has the station name, the arrival time, the departure time, the day, and the distance, right? And in station card, we have a card for every unique station. Same, now the data here is presenting what trains come to this station, when they arrive, when they depart, and on which days. Right. So that's the information we have. Everyone is clear with the matrix concept, right?
Yes, ma'am. Mostly the adjacency matrix you're talking about, right?
Yeah.
Yes, ma'am. Yeah.
Okay. So train data set information about trains, station cards, information about stations. Right. So what we do here is we compare pairs of stations. Okay. We take two stations and we see that whether they're connected by a train or not. So there are two types of connections that can happen, right? Let's take two stations, Kolkata and New Delhi. So they may be connected by a direct train that starts at Kolkata, ends at Delhi. So directly they're connected. Or in some way. Okay, maybe Delhi is in the route of that train. But just by taking that one train, you can reach to Delhi from Calcutta. Okay. Now, what is an indirect route? Let's say the train starts from Kolkata, then it goes to maybe Dhanbad. Okay. And then from Dhanbad, a separate train goes to New Delhi. So that way you can still reach New Delhi, but you have to change the train. So here this Dhanbad is that middle point, right? So this is called one hop. Okay. That is we are starting from Kolkata. We take that train, we reach Dhanbad. And then from Dhanbad, we take a separate train to go to New Delhi. So this is a one hop route because once we are changing the train, right? So like this, how many hops can be there? So there is something called n hops, right? So n hops, n minus one hops, like this, n number of hops can be there between two stations. So as long as they are connected, there can be any number of hops between them. Okay. So represent start and end station of trains in a nested dictionary. So here we will use nested dictionaries, right? So trains is a dictionary in which every train number, that is this T, is the key of the outer dictionary, that is trains. Okay. Now for every train number, there is an inner nested dictionary which is stored as the value of this train number. Now in this nested dictionary, there are different keys like start station, end station, distance. These things are stored in the nested dictionary. So trains, this is the dictionary. It looks like this. So maybe 12259 is one train. This is the outer key. Against this, there is one more dictionary stored as the value. Inside this is also key value pairs are present. So one is the start time, some value, arrival time, or let's say start station, some value, then end station, some value, whatever distance is covered, some value. Right. Like this information is stored for every train. Now, what are direct routes? So from station A, if I can reach station B such that a train is there which starts at A and ends at B. Like I said, it starts at Kolkata, ends at New Delhi. That's its route. Okay, then we can say that there is a direct route between stations A and B. So now we will write one procedure called direct routes. okay, which takes this train dictionary as your parameter or argument. So first, what do? We create one more dictionary called stations, okay, which is empty initially. Then for each T in keys of trains, this T is nothing but train number, right? So now in the stations dictionary, okay, what are the keys? So from this part, what can you say about what is the key of stations dictionary?
It would be the first station in that dictionary, right? In the Trends dictionary.
So let's say the first key. Okay, the first key in trains dictionary is the train number 12259. Okay, so that is this T. Wait. So this T is 12259. Now what is the nested key? Start. So whatever is the start station, right? Whatever is the start station of this 12259 train, that is the key of stations dictionary, right? So what are we doing here? For every station, for every train, okay, for every train, we are taking the start station and the end station, which are acting as keys in the stations dictionary, and we are assigning it the value true. Up to this, is it clear?
Ma'am, just one question which I have. So in the
Hmm.
so when we initialize the dictionary, so we
Hmm.
say that there is this nested dictionary to begin with, which is train of T and start, right? So T is the outer dictionary, which has the keys which are the train numbers, and the start is the inner dictionary, right?
Right. So for
So
every train T, there is a start end distance that is present in the nested dictionary.
yes, and this would be the Trends dictionary. So now when we go in the Trends dictionary, so the keys of the Trends dictionary would be the train numbers.
Yes, outer dictionary keys are train numbers.
Yeah, and when you were looking into this, the next in the line 4 of the pseudocode, when it writes stations of trains T and start, so in the trains T and start, T would be the first station that the train encounters, right?
Trains T. Okay, that's T is the train number, that is the key of trains dictionary. Okay. Now again, that train number a dictionary is stored, which has the start, end, and distance. These three keys.
Yeah.
So
Okay.
if the train number is 12259, then the start will represent what? At which station this train starts. So at trains T start, that station's name is stored in the dictionary,
Okay.
right? See, it's like
Mhm.
this. If this is the trains dictionary, so 12259 is the outer key. Now in the inner dictionary, it is like this. Start, maybe Kolkata it starts at. End, maybe Delhi. And distance, maybe let's say 1200 kilometers, something like this. So like this, there are more trains for which the same information is stored. So when I say trains T start, what value is stored? Kolkata.
Kolkata. Yeah.
So this value is going to come here. Okay.
Okay. Okay.
So
Mhm.
Kolkata forms the key for stations dictionary.
Okay.
Understood?
Yeah.
So it's basically like writing this
Mhm.
stations Kolkata true. So in
Right.
stations dictionary, the keys look like the key value pair is like this. If this is the dictionary, then you write for Kolkata true value, then for Delhi true value. Okay, whichever trains we encounter, for them, whichever unique stations are present, we are going to assign them true values in the station dictionary.
Okay.
Okay,
Okay.
up to
Yes.
this, only this much we have done. Okay, clear
Yeah.
for
Okay.
everyone?
Yes.
So after this is done, this part is done. In the stations dictionary, the keys will be what? All unique station names. Correct. All unique station names. And the corresponding value should be true. Now, N is storing what? Length of keys of stations. Right? So, whatever number of stations, that is, let's say in our data set, there are maybe 30 unique stations. Okay. So all those 30 stations, will they be present in this stations dictionary? We can't say for sure because that depends on the start and end stations, right? So the basic thing that we can say from here is that whatever trains we have, okay, let's say we have 10 trains. So all of them start at some station, end at some station, their routes. Okay. So if I say that all of them have, let's say, distinct um, routes, like they all start at a distinct station, they all end at a distinct station. So in that case, for every train, we have two distinct stations, and in total, there should be 20 distinct stations, and stations dictionary should have 20 distinct keys. Correct?
Okay. Yeah.
Okay.
But we can also have situations where like two trains they
Yeah,
start from
start
the
at the
same
same
station.
station. But
Yeah.
in stations dictionary, since they're keys, so they have to be unique,
Yeah. Okay.
right? And
Yes.
there might even be a station from which maybe no train starts there. Okay, maybe it's a middle station in every train's route. That is also possible. Okay, so what we are dealing with is only the start and end stations. We don't know anything else. So for every distinct start and end station, there is an entry in the stations dictionary. Okay. Now, any storing what? The length of the keys of stations. That is how many such start and end distinct stations are there. So whatever is the length of the stations dictionary keys, that is stored in N. Okay. That means why that is stored in N? Because that many direct routes are possible. Correct. See, N is storing this, okay, this length of keys, where we know that each of the keys are some start or end station. Now, direct is storing what? It is creating a n cross n matrix. So we first compile the list of stations from trains dataset, trains dictionary, and then we create a matrix to record direct routes. So whatever direct routes are there, since we know the start and end stations, whatever stations are stored in stations dictionary are definitely start and end stations of some train, right? So all direct routes can be found from this sample of stations, right? Every direct route possible can be found from this. Direct route means what? That a train starts at station A, ends at station B. So that's a direct route. So since we have all start and end stations, we can find out all direct routes. Is this okay?
Yes, ma'am. That's what n is doing, right?
Yes. N is storing the length of keys. Okay. That is
Yeah.
how many such stations are there. Now
Hmm.
we are forming we are forming a matrix which is n cross n in size. Okay, which is stored in this direct variable. So this is the direct matrix. Why we are creating this matrix? This matrix will keep a track of how many direct routes are there. So whenever we find a direct route, we will that entry. Okay, let's say for if this is the matrix, some rows and column values are there. Let's say for row I and column J. Okay, so this is some station I, some station J. So among them, if there is a direct route of a train which starts at I and ends at J, then this one will be 1. This entry will be 1. Okay. So this signifies the number of ones in the matrix will signify how many direct routes are there. So you create the matrix next. There is a station index, something called station index, which is again a dictionary. Okay. So see what is written here, map station names to row and column indices. Okay. So every station will be given some index of its own. That is, every station should have a unique index so that we can name them as row and columns. Okay, so index will start from 0. So I is equal to 0. Now, when I say for each S in keys of stations, what are the keys of stations? Stations
It is,
dictionary. What are the keys?
yeah, the station names, right?
Station names. Okay, so we want every station name to have a unique index of its own, right? So here in this for each block, we are just assigning indices to stations. Okay, before so that we can refer to them as this index and then create entries in the dictionary. this direct dictionary and all that. So before that, we need this index to be assigned to every station. So index is starting from 0. So whatever is the first station in the stations dictionary, the first key will be assigned 0. Then I is incremented. So for the next key, next station I will be 1. Like this, we will keep incrementing I, and every station will be having some index. So station index dictionary, this should look like, so maybe for Kolkata the index is 0, Delhi the index is 1, Mumbai the index is 2. Like this, it will continue for every station in stations dictionary. Right. So now every station has some index allocated to it. Next, see why these indices are necessary, because we are mapping station names to row and column indices. Okay. Because this is a matrix after all. Direct is a matrix. Now, once this is done, now we can populate the matrix. That is, we can assign values in the spaces in the matrix, every cell of the matrix. How we are doing that? So for each T in keys of trains. So now back to trains dictionary. Okay, that means for every train number, what we are doing? I is assigned as station index, trains T start. What does this mean? What is this part? Trains T start?
This takes the key of that station index from which the train starts from. Say for 12259, it starts from Kolkata. So Kolkata is assigned the sequence number 0. It takes out that index.
Correct. So for Kolkata, whatever is the index stored will be assigned to I. Right. Similarly, for the end station, whatever it is, whatever the index is assigned in station index dictionary, that index will be stored in J. So by this, so now see, in the matrix, we are not, what can I say? We are not referring to them as station names, right? We are referring to them as indices. The actual index to station mapping is stored in the station index dictionary. This is just to keep things simple. So in the direct dictionary, once we have stored, see, for every train, right? Let's take one example. Let's say this train 12259. Let's say it starts from Kolkata, ends at Delhi. Maybe Kolkata is assigned the index 0, Delhi is assigned the index 5. Okay. So I stores 0, J stores 5. Direct IJ. So first we know by convention, this first one is for row, second one is for column. Right? So for indirect matrix, we go to row 0, column 5 and assign the entry 1. Why we assign 1? Because we know that there is a direct route from this start station to this end station. Correct? There is a direct route. That's how did we find there is a direct route? Because one is a start station, one is an end station of the same train. That means it's definitely a direct route. So wherever, for whichever trains, okay, that are present in the trains dictionary, we will just take the start station, the end station, the indices assigned to them, and that corresponding row and column entry will be marked as 1, because these are direct routes. And after that, we are just going to return the direct dictionary. So how does the direct dictionary look like? Uh, sorry, direct matrix. So these are rows, these are columns, right? Now, tell me something. Since it is an n cross n dictionary, that means whatever indices come here, if there are six indices, then those six indices should be present here also, right? This is basic matrix. So every one of these indices, 1, 2, 0, 1, 2, 3, 4, 5, they're either a start station or an end station for some train, correct? So when we take any entry here, let's say row 0 and column 5. So this cell is 1. Whenever we see this 1 value in this dictionary, we know that there is a direct route from station 0 to station 5, where the train starts at station 0, whatever station is stored with that index, and ends at station 5 to whatever station is allocated the index 5. So direct route matrix will have all those direct entries assigned as the value 1, everything else will be 0. Is it clear up to now?
Yes, ma'am.
Okay. Now we come to one hop routes. So now direct routes are done. Direct means that one train joins two stations. One is the start station, one is the end station. That's a direct route. One hop route means that stations A and B are there such that you can reach station B from station A, but you have to change one train. Like I said, I can start from Kolkata, okay, and I can reach Delhi. Or okay, since Delhi was used in the last example, let's say I can reach Chennai, okay, but I have to stop at maybe say Bangalore. Okay, there is no direct train from Kolkata to Chennai. So I take one train that is direct from Kolkata to Bangalore, and then I take one more train from Bangalore to Chennai. Okay, this hop, this is called one hop. Okay, that is between two stations. So if this is station A and if this is station B, I want to reach station B from station A, but in between there is one more station through which I have to come. So since there is one station only in between, so it's an one hop route. Like this, there can be two stations in between. So maybe from Kolkata, you first reach some other station, then from there to Bangalore, then from Bangalore to Chennai. So that becomes a two hop route. Okay. But currently, let's just discuss one hop. So one station in between. That means one train is changed. Kolkata to Bangalore, I took one train. Then Bangalore to Chennai, I took a different train. Okay. So iterate through intermediate stations. Okay. So now I have to iterate through the intermediate stations. That is whatever comes in between. So we now will have one more matrix called one hop matrix. So since we have created the direct matrix and you know that only those stations, I'm sorry, only those entries are one, where between two stations there is a direct route, right? So in one hop matrix, which entries should be one?
In which there are no direct routes.
In which there is a one hop route,
To
right?
reach two stations, to reach one station, there are two routes.
To reach one station, I have to go through some intermediate station and change the train, and then take a different train to point B. Okay. So that is a one hop route. So see, set one hop ij equals to 1 if there is a connection via an intermediate station k. So in our example, Bangalore is that intermediate station k. So I have to check if from station, say Kolkata is assigned index I, Chennai is assigned index j. So I have to check if from I to k there is a train and from k to j there is a train. If that's so, then I can, in one hop matrix, I can write I to j. So in one hop ij, the entry will be 1 because there is a one hop route. Okay. So see here. N is what? Length of keys of direct. What are the keys of direct?
The station names which
Are in the rows and
yeah,
columns, right?
yeah.
So those station names are the keys of direct. So however many keys there are, those are taken, the length of that is taken into N. Now one hop matrix is created as an N cross N matrix again. Okay. So remember the flow. Okay. From trains, we created stations. From stations, we created station index. Then we created direct dictionary. Now we are creating one hop dictionary. Okay. Matrix is nothing but that only, right? Nested dictionary. So one hop is the name of the dictionary in which we are calling the create matrix procedure with n cross n as the dimension. So for each I in rows of direct and each j in columns of direct. Okay. Little question here. Let's say there are, first of all, if there are n rows, there are n columns, correct? Because this is a square matrix. So if this is a nested for each block, that means for every I, how many times will the inner nested this for each block iterate? If there are n rows and n columns, then for every column, every row I, okay, in the outer for each, how many times will the inner for each block iterate?
N times.
N times, right? So total, how many iterations will be there?
Square times.
N cross n, yes, n square iterations. Okay, so for each I in rows of direct and for each j in columns of direct. Okay, Now you take one more for each block, nested for each k in columns of direct. Okay. If now you check if I to k there is a direct route and k to j there is a direct route. That means I can definitely say that one hop ij will be one, right? Because we can go from I to k, then you can go from k to j. So I to j you can reach by one intermediate station k. Therefore, I can write that one hop ij entry is one. Everybody agrees with this?
Yes, ma'am.
So, like this, we are going to see all of these iterations are going to go on till we have exhausted every possibility. Okay. So, see, that's the beauty of this thing, that there are three nested iterations going on, right? For every I, there will be n number of j iterations, and for every j, there will be how many k iterations?
Again, in on
Again, n
KK
number.
generation. Yeah.
Again, n number of k iterations, right?
Ma'am,
So,
hello. Ma'am, can you
yeah.
please take on example dictionary, ma'am, for the dictionary which is filled with these trend records. At least the three records would be sufficient to understand this.
Okay. See, let's say this is the direct metric. Okay. So I'll say this is entry 0, 1, 2, 3, 0, 1, 2, 3. These are four indices for four distinct stations, right? Now this is direct matrix. So I create that from 0 to 2. Okay, there is a direct route, so the entry is 1. And then from 2 to 3, there is another direct route, so the entry here is also 1. Sorry, wait. 2 to 3 here. So what we are checking here, see, first for each I in rows of direct, right? So what is the first I? 0, starts with 0. Now come to the second nested iteration. For each j in columns of direct, what is the first j? That is also 0. Okay. Now again come to the third nested for each k in columns of direct. So now when I write for each k, okay, where is this k value starting from?
Again, starting from zero, ma'am.
So like this, if I go on, for every combination, I will check this. Every combination of ik and kj, right? Now one point it will come that I will check for each I in rows of direct. Okay, so it is still 0. Now the j value will change, right? Because we know that for every I, there will be n iterations of j. And for every j, again, n iterations of k, right? So when the j changes to 2, okay, when the j changes to 2, then you pick one more k, let's say for some k iteration, for each k in columns of direct. Okay. Uh, okay, for this example, let me modify this a bit. So I is 0. Okay. We are trying to go from 0 to 3. Okay. But in the direct matrix, I see that 0 to 3, there is no entry of 1. There is a 0 present. That means no direct routes are there. Okay. So I'm trying to find a one hop route. So for each I, here I is 0. Okay. And for each j, whatever the j is, now if I find such a k, obviously somewhere the 2 value will arise as k. Okay. And let's say at this point, at this iteration, the j value is 3. It can happen, right? That for I value 0, j has reached the fourth iteration where j value has become 3. Now for the fourth iteration of j also, all four iterations of k will occur. If I is 0, j is 3. K, if I start k iterations now, k will go through 0, 1, 2, 3, all four, right? So at some point, k will be 2. Now if I enter this for each block and check that is there a route between I and k? So what is I at this point? 0. K is 2. In the direct matrix sequence 0 to 2, there is a route. because one entry is present. So 1 equals to 1, correct. Again, you have to check, is there a direct route between k and j? So what is k right now? 2, right? And j is 3. So 2, 3. Yes, there is one entry. So 1 equals to 1. So both of these conditions are correct. Now I can write that one hop ij, that is one hop 0, 3 is 1. I can assign the value 1 because there is a one hop route present. So to check like this, to go through all the intermediate stations, you need to go through every possibility of k for I and j. Right? For every I and j, you have to check all possibilities of intermediate stations. So nested iterations is the only way to do that. Is this clear?
Yeah, ma'am, in this case, the one hop is another dictionary, is it?
One hop is a separate diction. It's a separate matrix.
Okay, okay. So direct hop is a parameter to this function which will take direct as a dictionary.
Yes,
Okay.
see,
Here we
no,
are doing another
direct dictionary exists. Okay, direct already exists. We have created it. Now we are creating one more dictionary with this procedure, one hop. Okay, where the dimension of one hop matrix is n cross n, and what is that n? It is nothing but the length of keys of direct matrix. So the one hop procedure takes the direct matrix as its argument. Okay, is this part clear for everyone? How the one hop matrix is created?
yeah, yes, ma'am.
Ma'am, I have one question.
Yeah.
Yeah, here you are checking j equals to 3. So here I can check j equals to 2, j equals to 1 for every
Yes,
row.
yes. See, for every I value, okay, I starts with 0. So for every I, j will iterate 4 times, 0, 1, 2, 3. Now for every j, k will also iterate 4 times, 0, 1, 2, 3. Okay. So first if I is 0, then next j is 0, then k will iterate how many times? For I 0, j 0, k 0, 1, 2, 3. Again I remains 0, j becomes 1. K will again iterate 0, 1, 2, 3. Like this for every j value, k will iterate through 0, 1, 2, 3. And for every I value, j will iterate through 0, 1, 2, 3. Understood?
Yeah, ma'am.
Madam,
This is a lit. Yeah.
sorry to interrupt. So the I and J I understood, madam, but the K value, how it's coming, I am not able to understand actually. So could you
K
please
is nothing but
repeat
these.
again, madam?
See,
So,
K is nothing but
for
these only.
example, I you consider as Z initial, then
Hmm.
J is iterating to 0 to 3, understood. Then from, for example, J is 0 means so I is 0, J is also 0, then K where that number will come actually.
From the columns only. Okay, from the columns of direct dictionary only. J and K are both
Uh,
taken. See, you
K,
can take K from your.
in left in left side you provided that matrix, madam. That area just tell me
Yes,
where it's
yes.
IJ. I understood. K where it is coming here.
See, K is coming from where? Columns of direct. That means these 0, 1, 2, 3 values only. Okay, every possible combinations we have to check. Right now, K is that intermediate station. Okay, so if
Mm,
0 is a start station for some train, okay, and 2 is an end station for some train, it can also
mm,
happen so that 2 is an intermediate station for some train, right?
okay. Mm,
So what we are checking is that if 0 is the start station and 2 is the end station, okay, then we are checking if 2 is the start station and 3 is the end station.
mm,
These like this we are checking that can we break down the direct route. Okay. So K is one such station which is a end station for some train and a start station for some train. See, the K value once goes into the column part, once goes into the row part of the direct matrix. That means what? Direct I comma K. It means I is the start station, K is the end station. Again, we are checking direct K comma J, where K becomes the start station, J becomes the end station. So our goal is to find that is there some K for which there is a direct route from I to J. Okay.
mm,
So for that to be possible, K has to be the end of the first train. So like in our example, if I go from Kolkata to Bangalore, I'm sorry, Kolkata to Chennai. Okay. So
okay.
Kolkata is my I. So
Okay.
from Kolkata to Bangalore, Bangalore is my K. Here I have one direct train. Again from Bangalore to Chennai is my J. Bangalore to Chennai I have one direct train. So I can
Oh,
say that just by taking this one hop, I can have a one hop route.
okay. Got it. Got it.
Okay. So in one hop matrix, Kolkata Chennai entry, that is IJ entry, will be 1 because there is one such intermediate K through which we can do this journey.
Ma'am, will
Okay.
not it be a long procedure to check again and again and again?
Sorry,
Like
sorry, come again.
then for every I and J we have to check K.
I did not understand. Can you repeat?
Ma'am, will not it be a very long procedure to check
Yeah,
every?
it is long. Okay, this will take a lot of time. This will take order of n cube time. Okay, because there are three different for loops running, right? So whenever we have one for loop running, it takes order of n times because there are n iterations. Okay, this is from algorithms. Okay, so you don't need to understand the timing complexity now, but I'll tell you. Whenever we have a single for loop like this for each block that we call it now, it's basically a for loop. So this loops how many times? Until the for condition is exhausted. That means until we have gone through all the rows of direct matrix. So direct matrix has n rows, right? So the for loop, just this first for loop will iterate n times. Now the second for loop is iterating how many times? For every entry I, second for loop, j for loop will iterate n times. N cross n total n square time it will take just with these two for loops. Now there is a third for loop also, where k will iterate n times for every j value. So n cross n, one n for every for loop. So it will take an order of n cube time, which is a very bad timing complexity. Okay. But for this procedure, they have implemented it in this way. It will take a long time, but it's going to give you the correct result. Okay.
Thank you, ma'am.
Yeah. So this is your one hop dictionary we have created, direct dictionary we have created. Now what they are saying that set one hop ij1 if there is a connection via intermediate station k. More useful to let one hop ij mean connected with at most one hop. Okay. So what does this mean? At most one hop, that means either 0 hops or 1 hop. 0 hops mean what? Direct route. No hops. No intermediate K is required. So it is always useful to include the direct dictionary inside the one hop dictionary. Okay. Why so? Because see, if two stations don't have a one hop route, they might still have a direct route. Correct. See, if I draw this dictionary or matrix, whatever you call it. Okay. This is my one hop dictionary. Okay. So by what we have learned till now, in the one hop matrix, if I write that from row 2 to column 3, this cell has a value 1. In one hop dictionary, it means that there is some intermediate route to a station K which connects stations 2 and 3. Correct? Now what they are saying is, in the direct dictionary, if there was a route from 0 to 1, direct route, then that one entry should also be included here. Okay. So this one hop dictionary now means what? If you see a 1, if you see a 1 in this dictionary, in this matrix, anywhere if you see a 1, it can mean that either it's a direct route or it's a one hop route. So it is at most one hop. That means two stations, between two stations in this dictionary, if you find a 1 in the cell. So if I see that from station 4 to station 3, there is a 1 present in this cell. So I can say that either it is a direct route or it is a one hop route. That means we are absorbing the direct dictionary into the one hop dictionary to make it more useful. Okay. So now the procedure is called within one hop. Within one hop, why? Because now it can be either 0 hops or one hop. So n is still what? Keys of that direct dictionary, length n. Now one hop dictionary, you again create it. Okay. Now for each I in rows of direct, see this part is exactly same as the previous one. We are creating the one hop dictionary again such that it also takes everything that was present in the direct dictionary. Okay. So one hop dictionary create matrix n cross n. Now for every I in rows of direct, every j in columns of direct, after these two. Okay, see the previous code. Every I in rows of direct, every j in columns of direct, we directly went to every k in columns of direct. But now what we are doing, we are taking the row and column value. Okay. And then inside the second for each, we have one more statement that one hop ij is equal to direct ij. So once we have row and column values, we are first checking that whether for that, okay, for that entry, for that I and that j, whatever entry is stored in direct dictionary, that will be stored in the one hop dictionary as well. Like if this is the direct dictionary, okay, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So this is direct. So if in direct dictionary from 0 to 1, there is an entry 1. Okay. So we check the iterations here. I is 0. So for I 0, we'll start with J 0, then J 1. As soon as J becomes 1, okay, you can directly go to the direct dictionary and you can see that, okay, for 0 to 1, I have an entry 1. So that entry will be stored in one hop ij. That means one hop 0, 1. This entry will be stored as 1. See, one hop ij is assigned whatever is stored in direct ij. Even if it's a 0, that will also be stored in one hop. Understood? Up to this, is it clear? Just this line.
Okay, so it also stores those elements in the direct dictionary as well.
In direct dictionary, yes.
Yeah.
So first what will happen for every row and column? Okay, for every row and column, for every iteration, we will take the direct ij value and store it in the one hop ij value. Okay. We are not checking for one hop till now. We are just assigning the direct ones. Okay, with no hops. Next, after this is done, then we will go for the k value. Okay. So for every ij, first you take the direct value, direct ij value, store it in the one hop ij value. Now you check that whether there is a one hop root as well. So now after, see, this is also a possibility, right? That from 2 to 3, I can have, or okay, let's continue with this one. From 0 to 1, I have a direct route. Now from 0 to 1, I may have a one hop route as well. Maybe some train goes from station 0 to station 2, and then from station 2 to station 1. That is also possible. It's just a roundabout way of going from 0 to 1. But if there is a one hop route present, we have to find that also, right? Because this dictionary stores what? Connected with at most one hop. This at most is the important word. But either 0 hops or 1 hop. For both, the entry will be 1. So once we have already absorbed all the direct matrix entries in the one hop matrix entries, then we will check for the intermediate routes that via some station k. And rest is same. So let's say if for okay, what example I can take? Let's say in direct dictionary from station 1 to station 4, there are no routes direct. So it is 0 entry. So this 0 entry will be first stored here also in the one hop dictionary 1 to 4, 0, because of this line. Then we come to the nested for each k. Okay. And now we are looking for some k value, intermediate k value, through which I can go from 1 to 4. So maybe I will find some station 2 that I can go from 1 to 2 and then 2 to 4. So in that case, this condition will give 2 and one hop ij value will be changed here from 0 to 1 because some root hop has been, one hop root has been found. But initially, every entry will be same as the direct entry. Then we are checking for the one hop entry. So after all of this is done, the one hop dictionary will represent both the direct routes and the one hop routes. Is it clear?
So, what would have happened if in this if the in this if statement we would have included the statement and direct ij equals 1?
And direct ij equals 1.
Yeah.
So that means so you're checking both things, that there is a direct route also and a one hop route also. Okay. But
Yeah.
in this code, there is no need for that because we are already absorbing all the direct entries in this statement.
Okay.
Okay. So first, every ij entry will have whatever entry was stored in direct matrix. So whether it was 0, whether it was 1, that thing will be stored in one hop matrix. Next, we are checking for the one hop route. So now some of the zeros, that means some of the routes which were not direct, will be turned into 1 because there is a one hop route. So this one hop ij, which was earlier storing the direct ij value, might be turned into one hop ij equals to 1 if this condition is true, if there is some intermediate k station. So even if two stations don't have a direct route, they might have a one hop route. So after this, all the iterations are done, then one hop matrix will represent both things, right? Direct routes as well as one hop routes. Yeah.
Just the other question that I have, when we have this the other line where we have mentioned that one hop ij equals direct ij. So
Hmm.
if this gets implemented in the first case, that is, we have find that there exists a direct route between I and j. So will is there a necessity for checking the next condition? So if this is
Yeah, see,
same,
what we are trying to check is if there is a direct route. Okay, that's very good. But we are trying to find if there is a one hop route as well, right? See, this procedure name is what? Within one hop. Means either there are zero hops or there are one hops. So both information should be reflected in the one hop matrix. Okay, so if direct ij for some ij entry in the direct dictionary, if one is stored, then in one hop dictionary also in that same ij entry, one will be stored. Okay, but you will still check that, okay, if is there any such k through which I can go from I to j? If okay, if there is some k, then fine, because we are still assigning one only, nothing will change. But when will the change occur? If in direct dictionary from I to j, from for some ij, the entry is zero, that is no direct routes are there. Then initially in one hop dictionary also from I to j, it will be assigned zero because of this line. But next we check, is there a one hop route? If we find a one hop route, then this entry will be changed to 1. So after all the iterations, you can see in the one hop matrix, it will represent both direct routes as well as one hop routes.
okay, so that's why the at most comes. Either you take 0 or 1.
Yeah, either you take 0 or 1. That's why at most.
Okay.
Okay, is this code clear for everyone? Okay. Now we'll just go to, now see, the rest of this part is just generalization. Okay. Once you understand 0 and 1 hop, so that is direct and one hop. Now you can extrapolate this to two hops, three hops, n minus one hops, anything. Okay. So now two hop routes means what? A to B. You can go such that you can reach B from A by changing at most two trains. At most two trains. Okay. This word is very important because from now on, what will happen? When I create a two hop matrix, it should also retain every value from the one hop matrix and the direct matrix. That's why the word at most comes into play, these two words. At most means either you can go from A to B by 0 hops or by 1 hops or by 2 hops. Okay. So to preserve this, we must absorb all the values from direct and 1 hop matrix into the 2 hop matrix as well as the 2 hop entries. Right. This is just extrapolation. Now, if you say that I need such a matrix which takes n hop routes. So in that n hop matrix, you should have every entry from direct to n minus 1 hops. Understood?
Just here. So when we have these two hop routes, so we'll have three things to be declared, right? So once we'll take this direct matrix plus the one hop matrix, and we'll feed in these two
That
matrices
yes,
inside. Yeah,
yes. You
and
need
then we.
direct one hop and then you will create the two hop entries.
Okay, yeah.
Okay. Then again for three hop, if you go, you will take direct one hop, two hop, and then create the three hop entries.
Okay.
Okay. So this gets more complicated as you go towards n hops, that generalization. So see here, if I am going for two hop routes, okay. So one thing is that I have the direct routes, I have the one hop routes. Now from the one hop routes, I can create the two hop routes. How? So maybe I want to go from Kolkata to Dhanbad to, I don't know the exact order. Okay, I'm just taking random stations. Let's say Kanpur and then Delhi. If I take this, that means I don't have any. I don't know if I have direct routes from Kolkata to Delhi. I'm just looking for a two hop route. So I can find in the one hop matrix that I can go from Kolkata to Delhi. I'm sorry, Kolkata to Dhanbad, and then Dhanbad to Kanpur. Okay, and then from Kanpur I can go to Delhi. So basically, see, extend a one hop route from I to K by a direct train from K to J. So this is my one hop route. Kolkata to Kanpur is my one hop route, where the K intermediate K is what? Dhanbad. Okay. Or if this is difficult for you to understand, let's say that let's take another variable. Maybe Kolkata is my I, Delhi is my final, so let's call it J. Let's call Kanpur as K. Let's call Dhanbad as L. So via some intermediate station L, I can reach from I to K. So this becomes my one hop route. Plus, I need a direct route from Kanpur to Delhi. That is K to J. This part becomes my direct route. So taking these two together forms a two hop route. Understood? A one hop route and a direct route. So extend the one hop route from I to K, where I is Kolkata, K is Kanpur, hopping through Dhanbad, which is L. This is the one hop route, and then a direct train from K to J. So Kanpur is K, Delhi is the destination J. This is a direct route. Taking this one hop and direct together, we form a two hop route. Concept is clear for two hop?
The direct route would be still from Kolkata to Delhi, right?
Can be there. Okay, but we are anyways, see here also, in this code also, direct route may be there between any ij, but regardless, we are still checking this condition, right? That is there a one hop route. So for every ij, we have to check whether there is a direct entry, whether there is a one hop entry, whether there is a two hop entry. Everything we have to check. Okay, so this is two hop, one hop plus direct. So now we have to implement this in code. So extend one hop route from I to K by direct train from K to J, iterate through intermediate stations, combine information in both direct and one hop. So see, in this procedure, we have two parameters, direct dictionary plus one hop dictionary. Both of them are passed as argument, right? N is again length of direct keys, right? Everything is same. Okay. Except here, we are creating now a two hops matrix, because one hops matrix and direct matrix are both created. Think of it like this, okay? That this is a big program with multiple procedures. First, we create a procedure to create the direct dictionary, then one hop, then two hop. Like this, it can go up to n hops. Okay. So two hop dictionary, now I'm creating same n cross n matrix. See, for each I in rows of direct, for each j in columns of direct. So what did we do earlier? In one hop, we were storing all the direct entries. Now in two hops, we are storing all the one hop entries. Is this part, can you relate this part to the earlier code?
Yes, ma'am.
See,
Yeah,
one
because
hop
we need
already
to.
has everything from direct as well as one hop, right? So if I put that in the two hop, everything from direct and one hop is now stored in two hops. Now, it can happen, right? That there is some station I and J between whom there are no direct routes, no one hop routes, but a two hop route might be present. So even after I take the entries from one hop and store them into two hops, some entries will remain zero, which will later turn into one if I find a two hops route. Okay. So first absorb this one hop dictionary into two hops for every ij value, and then check for a intermediate k such that there is a one hop route from I to k and a direct route from k to j. If both of these are present, then I can say that there is a two hops route from I to j. So two hops ij will be assigned as one.
Ma'am, instead of these codes, can we identify two hop routes by using graph?
This is graph. This can be much better represented using graphs. Okay, so there is a question in the practice assignment which we will do that's based on graphs. Okay. See, anything that you can represent in a matrix can be represented in a graph and vice versa.
Ma'am, can you please give one example of finding the two hop routes through graph by checking the code also?
See, if I have, let's say these are the nodes. Okay, 1, 2, 3, 4, 5. Let's say I have 5 nodes. Fine. Now I can see, okay, let's say my I and J are, so 1 is my I, 4 is my J. So I am trying to find a two hop route from station 1 to station 4. Okay. Now in my graph, I can see that there is a direct route from 1 to 2, okay, and a direct route from 2 to 3, a direct route from 3 to 4, and a direct route from 4 to 5. And again, let's say some direct route from 5 to 1, if this is my graph. So in that case, if I call this K, can I say that there is a one hop route from 1 to 3?
Yeah,
Yes.
Where
ma'am.
2
2
is
is
the
there.
intermediate station. So this is my one hop route. Once I reach K, from K to J, can I say there is a direct route?
Yeah, ma'am.
So these two combined makes from 1 to 4 a one hop plus a direct. That is a two hop route. Clear? Any question from this part?
And now can you please construct a graph from it? Graph, no, sorry, ma'am. Can you please construct a matrix from it?
So then you'll have to construct the direct matrix, the one hop matrix, and the two hop matrix. So I don't have the other entries, but if you want to see in the direct matrix, okay, I have started from 1, right? See, in the direct matrix, if this is the direct matrix, there definitely will be, which entries will be 1? From this graph, I can tell that there is a direct route from 1 to 2. So 1 to 2, this entry is 1. 2 to 3, this entry is 1. 3 to 4, this entry is 1. 4 to 5, this entry is 1. And then 5 to 1, this entry is 1. In the direct matrix, these entries will be 1. Am I correct?
Yeah,
Yes.
ma'am.
Okay. Now, if I create the one hop matrix, remember, I am absorbing all the direct matrix entries into the one hop matrix. So initially, I can just write all these ones as they are placed, right? These will definitely be there. Now, along with them, there might be some extra one hop routes. So 1 to 3, can I say there is a one hop route? Yes. So 1 to 3, I can add one more one. 1 to 4, is there a one hop route?
2 hop route.
So
It's a
in
2
one
hop
hop
route.
matrix, it won't be an entry. Similarly, from 1 to 5 also, there is no one hop route. From 2 to 4, is there a one hop route?
Yeah, ma'am.
So 2 to 4, another one you can add. From 3 to 5, there is a direct one hop entry. So from 3 to 5, again add one more one. From 4 to 1, there is again one more one hop route. So 4 to 1. 5 to 2, there is a one hop route. This one, where this is intermediate. So now you can also add one here. So see, the ones that were present in the direct dictionary are preserved in the one hop dictionary, as well as some new ones have appeared because of the one hop routes. Okay, now if I try to turn this into a two hop dictionary, all of these ones will be preserved. Plus, I will find some two hop routes. So let's change this dictionary into a two hops dictionary. Now you will tell me which entries will be two hops. So if I start from 1, what is the two hop entry?
So 1 to 4 would be a 2 hop entry.
So 1 to 4, I can add one more one. Next,
And 2, 5,
2 to 5. So 2 to 5, this entry will be 1. Again,
3, 1,
3 to 1.
and 4 to 2.
3 to 1.
Yeah.
This one. 4 to
And
2.
2,
Anything else we're missing?
5
5
to
to
3.
3 also.
5 to 3. Nothing else.
Yeah.
Yes.
Is it clear now how it works?
Yeah, ma'am.
Yes, ma'am.
Okay. See, these things are actually very easy. Just the pseudocode looks difficult to use. Okay. Just think like this. If there is a direct route, there is a possibility of a one hop route or a two hop route or an n hop route, right? So when I create that n hop routes dictionary, okay, n can be any number. If I create an n hop routes dictionary, it should take all the other entries from direct to n minus one hop routes. Correct? Because those should prevail. After that, on top of that, I should try to find if there are more n hop routes, right? Up to n minus one hops, I have already found. So prevail those entries, plus try to find n hop route. So it is always like that, n minus 1 plus 1 hop. Got it? Okay. See, this thing is that n hop roots. Okay. So in n hop roots, what it is written, let n hops record connections from station A to station B by changing at most n trains. Again, at most. That means where are we starting? At direct. Then direct 1 hop, 2 hop, 3 hop, 4 hop, up to n minus 1 hops. Okay. And then that extra hop. That makes it n hops. That same thing. Like in 2 hops, what did you do? Direct 1 hop and then 2 hops. So want to extend n hops to allow one more hop. That is n minus 1 hop plus 1 hop. Okay.
Well, in this case, starting point can be anywhere, right?
Anything, yeah. See, it will be like this. So what did we check in that previous example? That for a 2 hops route, I need to find a 1 hop route plus a direct route from K to J. So in n hops, it will be, I have to find a n minus 1 hop route from I to K and then a direct route from K to J. That's what I think. Yeah. So n hops records connections from station A to station B by changing at most n trains, right? See this. 2 hops when we are working with, if 1 hop ik and direct kj are 1, then I can put 2 hops ij as 1. Okay. Same thing, just relate to here. So this is a one more hop. Okay. One more hop. So by now we are saying that we have created n hops. Up to n hops I have created. Just like 2 hops, 3 hops, 4 hops, up to n hops I have created. Now I am creating another procedure called one more hop. So n can be anything plus 1. Okay, n can be 0, n can be 1. So just one more hop means plus 1. So if I can reach a station B from station A by changing at most n trains, that is your n hops matrix. Now we want to extend n hops to allow one more hop. So iterate through intermediate stations again. Now what will it be like? Combine direct and n hops. So that means now I'll go from I to K via an n hop route and then a direct route from K to J. That means this one more hop is nothing but n plus 1 hops. Is this clear up to this?
This K to J is the last hop, that is a plus 1.
Yes, this K to J is the direct route. Okay. And from I to K, there should be an n hop route. Just like in 2 hops, we found that from I to K, there is a 1 hop route. Then K to J, there is a direct route. If it was a 3 hops dictionary, a 3 hops matrix, it would be I to K, there should be a 2 hop route plus a direct route from K to J. So this condition is always like that. Okay. If you're finding an n hops route, then it should be n minus 1 hops from I to K and a direct route from K to J. Now this is n plus 1 hops. That means from I to K, there should be an n hops route and a direct route from K to J.
Okay, ma'am. In this case, with respect to this context,
Hmm.
direct hop is a zero hop, is it?
Direct route is the 0 hops, correct.
Okay.
Okay. So see, everything is going same. Now we are just creating a dictionary called one more hop, right? This one more hop means n plus 1th hop. Okay. So for I and J, again in this direct rows and columns. So what do you have to do? You have to absorb the previous entries. So n hops is the last dictionary I've created. So n hops ij should all the entries from n hop ij should be stored in one more hop ij. Then you check for a one more hop, right? That is n plus 1 hops. Is there a route that has n plus 1 hops? So you check that from I to K, some intermediate K, is there an n hops route and a direct route from K to J? If so, then one more hop ij will be 1. Instead of calling it one more hop, I just like to call it n plus 1 hops. Okay, because that's easier to understand since we are going in a mathematical progression, right? You ask me any doubt till now?
Ma'am, can you please construct a 3-hop route through this?
3 hop routes, like 3 hop matrix, right?
Yeah, ma'am.
See, uh, this same code you can just tweak it. So now if I want three hops, here first I will create a three hops matrix, right? Instead of two hops. Everything will go same. Here just change this to three hops and this to two hops. Whatever is the last matrix you have created. Then for each k, I'm going to check if there is a two hop route and a direct route from k to j. If this is true, then three hops ij will be 1. Understood?
Yeah, ma'am.
Should I repeat this?
Just tell where is P of in the graph.
I do not can't hear you. Where is three hops?
In the graph.
In the graph. Okay. See, three hops means what? From I to k, there should be a two hops route. Okay. So from 1 to 4, is there a two hops route present?
Yeah, ma'am.
So one hop from 1 to 3, direct from 3 to 4. This comprises of a two hop route from 1 to 4. And then one more direct route from 4 to 5. So I can say from 1 to 5, there is a three hops route. Understood? Two hops till 4 and then one direct route till 5. Clear?
Yeah, ma'am.
See, these things you have to imagine a little, right? Can't see when this goes into higher orders, you won't be able to write all of this in graph format in exam. You have to imagine a bit. So just extrapolate the imagination. Till two hops you can write, everything is fine. Then when you go to three hops, just imagine that in two hops, what did I do? I did one hop route plus direct route. This means two hops route. So three hops, if I generalize, means two hop route plus direct route means three hop route. Similarly, for four hop route means three hop route plus direct route is four hop routes. Like this. Just generalize like n hop route means what? N minus one hops route plus direct route. Okay, I hope this is clear.
Yes. Can you say that a one hop route is a direct route?
One hop route is not a direct route. One hop means there is one change in train. Direct means there are no hops at all. That means I is the start station, J is the end station. One hop means there is some station K in between through which we have to go from I to J. Okay, at that station K, we are changing the train. Clear?
Mhm.
Can we practice the questions now a bit? Because up to this is the important part in the theory. Now, if you do the questions, you'll have a better idea.
Yes, ma'am, I'm going with the questions.
Yeah. If you have any more theoretical doubts, you can ask in the next session also. Okay. Hmm. Oh, this is not yours. Wait,
Yeah.
just a second. Let me download that PDF. Week 10 and week 11 are the last actual content. Okay. Week 12 is, there is no such content in week 12. And from exam point of view, if you see, maximum weightage of questions will come from list dictionary and graphs, graph matrix. Okay, in n term.
Ma'am, and one more question. From week 1 to 4, what will come in CT?
1 to 4, just the quiz one questions. If you practice, that's enough.
And one more thing I wanted to ask, do questions repeat in that and term?
Repeat, maybe some values might be changed. Yeah. Yeah, repeats are there.
Thank you,
Values
ma'am.
will be changed, but yeah, question concept will be same. Okay. Is the practice assignment visible?
Yeah,
You
ma'am.
can zoom it a bit.
Yeah. This is okay.
Still in the same zoom, I guess.
Just maximize the
Wait, this is okay?
Still the same.
I have changed. This is the maximum zoom.
Okay, maybe.
Reflected and share
Wait,
screen.
wait, I'll try to reshare once again.
Ma'am, hello.
Check now. Yeah,
Yes, ma'am.
This is perfect. This is perfect.
okay.
Yeah.
Sir told me question 5 was done. Is it done or not done?
It was not done. Till question 4 it was done.
Okay. So 5 questions left. See, now that you have understood those procedures, these will be very easy to do. Okay. So question 5 is saying some procedure is a procedure name, okay, that accepts 3 parameters. Just a second. Yeah. So it is a procedure that accepts 3 parameters, a train, a station, and the matrix. Okay. A matrix A that was computed in the previous question. Okay, so these are part questions. Are you sure this was not done? Part questions are usually covered together.
Yeah, I think it was done till this point. Yeah.
A
Use it.
matrix. What is the A matrix here?
Yeah, it was the last. It was from the last question. The A matrix is the input from the last question.
I don't see any A here. Okay, okay, this one.
Yeah.
Okay, let me just read once what this is. So IJ is a pair of stations. Which of the following statements are true after executing the pseudocode? Is this a comprehension? Are all of these connected?
Yes, ma'am.
A
So
matrix as input. Oh God, this is from like question 1. You're using A matrix. Okay. Okay, so I'll just check this code, then I guess I'll understand A. Okay, so this is train dictionary. Okay. So S is another dictionary in which train sequence number, I hope this is. X dot sequence number is a train sequence number. That's right.
the
Okay,
station
this is the
sequence number.
sequence. This is the sequence number of the card, right?
Yes, the station sequence number.
Okay, 1 second. Let's check what is X. So this is the condensed version of trains data set. There are total n stations with stations been indexed from 0 to n minus 1. Okay, these are the sequence number of the stations, correct. Got it. In kilometers, in trains, for each tree will occupy multiple rows in this table. So for every train, there can be multiple entries, right, in the table, because this is based on the stations. So stations will be unique. So S is a dictionary in which the outer keys are station numbers, right? Sequence numbers, these are unique station numbers.
The outer keys should be the train numbers, right?
No, this X dot sequence number, right? This is what?
Oh, I
See,
see. Okay.
sequence number is this one. Okay. And it is saying that here stations are being indexed from 0 to n minus 1.
Okay.
So it is saying here, see, each train T will occupy multiple rows in this station table because a train can go through more than one station, right? So this sequence number is the station sequence number. Okay, this X dot sequence number. Then for every such station sequence number, another nested dictionary is present in which the keys are train, departure, arrival, distance. Okay, so it looks like this. S dictionary is like this. So for station index 0, there is a dictionary where you have entry for train, departure, arrival, and distance. Like this for stations 1, 2, up to n, whatever it is, n minus 1. Okay. So once these information are stored, see all this information is coming from this table. Okay. This table. Train, departure, arrival, distance. So these four are acting as the keys of the inner dictionary for every sequence number, every unique sequence number. Okay. Now A dictionary, A matrix, how it is created? It is an n cross n matrix again. So for each R in your rows of A,
Hello, ma'am. Just to sorry to interrupt, ma'am. Just I would like to understand the dictionary part here. Just some clarification required. Zero, one, two, three are no the key, right? For that, no train departure arrival is another value for that. So now, how can that be internal dictionary actually?
wait, I did not understand. Can you come again?
See, S is the dictionary, and zero,
Yeah.
one, two, three, four are the keys, and then
Yes.
for the corresponding key values are train departure and arrival and destination, or
Yes. Distance. Yeah.
a distance. So now, again, T is a one more dictionary, is it?
No, no. See, T was the original train data set. Okay. Here, trains are not unique in this table that is provided to us. What is unique is the station. Okay. See, it is written here that there are a total of n stations with stations being indexed from 0 to n minus 1. So these are all station indices. Okay. Now for every station index, there is some train number given, its departure and its arrival is given, and that is it departs from station 0, arrives at station 1, covers a distance of 266 kilometers. Now similarly, it is saying that there can be multiple rows for the same train. So maybe some station index R. Okay. Here also the same train 12259 comes at some point and departs this station and arrives at another station. Okay, so there can be multiple entries for the same train. Here train is not unique. Okay, what is unique is the station index. See, for example, the rth row tells us that train T departs from station I, okay, arrives at station J, and after covering a distance of d kilometers. So maybe it can be, for example, we can take it like this. If R, for sequence number R, if the train is also 12259, okay, then what is the original departure for this train? Maybe it departs from where? Here you can see
Zero.
0. And maybe it arrives at some R plus 1 index. Okay, covering some d distance. So like this, there can be multiple entries for the same train. That's what it's saying. The unique part is the station sequence. Okay, that means for some other station also here, the t value can be the same train. Here. Okay. So once this dictionary S is created, now we are creating a matrix A where for each R in rows of A and for each C in columns of A. Okay. ARC is an empty dictionary. This would be better if any of you could remember what the A dictionary. Okay, okay, here it is given. So for each X in keys of S, okay, so for every distinct station index, R is the departure index, departure station index. Arrive is the arrival station index, T is the train number, and D is the distance covered. So all of this information is coming from S dictionary, and it's storing in these variables R, C, T, and D, and they are actually different keys of the A dictionary. So A is from this. What can you tell about A? Is A a nested dictionary?
Yes, ma'am. A is a matrix in which the elements of these matrix would be a dictionary that stores the train number and the distance
So
between
R, C, T, right? First, for every row and every column, the entry is a dictionary, which is the train, and the corresponding value is the distance. I think I think that's correct. Yeah.
yes, ma'am.
Okay, if that's the case, then yeah, let's see this question. If ij is a pair of stations, which of the following statements about dictionary ij are true? Each key corresponds to a train that goes from station I to station J. Is that so? R C means departure, arrival. Yes, goes from station I to station J, fine, without stopping at intermediate station. Is
Yes.
that true? Yes.
Yes.
So this should be correct. Each key corresponds to a train that goes from I to J, may stop at multiple stations. No. Value corresponding to T of the dictionary is the distance between stations I and J on T's route. This is also correct.
Yeah.
And value corresponding to T of dictionary is the minimum distance between I. No, that's not correct. So A and C, I think.
So which means
Yeah.
the dictionary A will contain only the distance between the each stations.
Yeah. See, A is a matrix, okay, where the row and columns are the arrival and departure station indices. Okay. And the actual entry in the cell is what? The dictionary where train is the key and distance is the that is the distance this train has covered from the departure to the arrival station.
Ma'am, just to imagine, can you just give an example for the two rows, or some sample
Example.
records data for this matrix A? Say for example, let us take the 0th index.
See, it can be like this: 0, 1, 2, 3, 4. These are all station indices, right? Now, if
No, no, ma'am,
yeah,
sorry. I'm trying to understand from the dictionary point of view, not from the matrix. So, say for
see,
example,
dictionary point of view means for some row R and some column J, okay, for some row and some column, there will be a train entry also, okay, that is from this row and column is what? They are representing what? The departure and the arrival station, right? T is what? The train that is departing and arriving at these stations. And the corresponding value stored in the dictionary is D. That is, this much distance has been covered. This the key for this D is P in the nested dictionary. Okay. So for every T entry, the D is the corresponding value in that row and that column. That
okay,
means
ma'am,
the
just to
train
understand,
T, yeah, go on.
yeah, just to understand this only the dictionary part. Say for example, I'll write A, and first row will give a zero. Say for example, and then which is a key, and then corresponding value is again another dictionary. So what
Yeah,
that would contain? Can you just clear it up so that we have easy?
I think it would be like
Yeah.
this is the dictionary.
Yes.
So
Okay.
R is one first key. Okay. Inside that there is, wait, let me also correctly understand this. A, R, C, T. That means three keys are there. So inside this C should be another key, right? For which there should be a train value, which has the value as D. I think this is the way it is presented. So R is the outermost key.
Okay.
Okay. Now this is the departure. So for this departure, the corresponding value is another dictionary, where this is the arrival, and that is also another dictionary where train is the key, and the corresponding value is the distance between R and C that this train T takes.
Yeah, that's what I initially asked. So this each row and column in a matrix will contain the distance between each station. Then.
Yes, R and C, it is D is the distance between R and C covered by train T.
Yes. Okay.
Okay, so I think this is what matrix A is doing. Now let's try to solve this question 5. Sir told me after question 5, so I did not check this. I started from question 6. So I forgot this part. Let's see. So some procedure is a procedure that accepts three parameters: a train, a station, and a matrix A that was computed in previous question. Which of the following statements about its return value are true? Okay. So we have a train number, a station, and a matrix A. So for each R in rows of A. Okay. Rows of A are what? Station indices. If is key. What are we checking? That whether this is a typo, this is train. So whether this train is a key of the R station dictionary, that is RC basically, right? So where station is acting as what? The arrival station. So RC, like we saw in the dictionary, what was the format? R, C, D, and the corresponding value is D. Correct. So T is definitely a key of this ARC dictionary, just like C is a key of the AR dictionary. So it is checking whether this train is a key of A station C. I'm sorry. First, it is checking AR station. Okay. If the train is already a key, then for each C in columns of A, again we are checking if train is a key of station to C. If both of these are correct, then return false. So basically, it means what? See, let's name them. Okay. So I'll say that station here is Kolkata. Okay. So from in dictionary A, R, Kolkata. What does this mean? R is the departure station. Kolkata is the arrival station. For that, if the train number that we have passed, let's say 12259, is this a key in the A dictionary for this arrival and departure? Okay. If that is true, then you come here. Now check for each C in columns of A. So we are checking that is this train going from R to Kolkata and Kolkata to C, correct? Here, this is Kolkata starting, this is the end station. So if we are checking whether it's going from R, whatever R station is, to the index for Kolkata. Okay, let's say the index is 05 or something like that. So from R to that index and from that index to C. Okay, if the same train is going, then we will return false. Otherwise, you return true. Where is this return true statement coming? See, this if closes here and this if closes, this for closes here. Okay. So when will we return true? When can we return true? When there is such a train, okay, which goes from R to this Kolkata index, okay, but doesn't go from Kolkata to some index C. So in that case only we can return true. So I think only that is the case, and then this will stop here. But the overall return statement is false. So when will this return statement be executed? When can this return statement be executed? See, three return statements are there. This one will be executed when we find a train which is a key of AR Kolkata. That means starts from R, ends at Kolkata. Okay. And then we find some C for which that same train starts from Kolkata and ends at station C. If both of these become true, we directly return false and exit the program. Okay. Now this is one possibility. Another possibility is what? Another possibility is what? Where is this statement executed? Tell me.
In the next statement, right, where there is return true.
Yeah, this line 9, when will this return statement be executed?
So if say if the line 3 is true,
If line 3 is true. So if we find a train 12259 which starts at R and ends at Kolkata, right? If this becomes true, then we enter this for each block, but we don't find such a C for which this train is starting at Kolkata and ending at C. Okay. In that case, it will come out of the for loop that is here and it will return true. Now, in which case will this be executed? If 12259 is not a key of this at all, right? For any R, if the line 3 never becomes true, if the line 3 never becomes true, then you have to return this false. That means for any station R, there is no such train that you can, that the train that you are passing, okay, For any R, it hasn't started R and ended at this station. If there is such a train, then it will return false. Let me check the options once to understand. Some
Just to clarify thing. So STN is the starting station or the ending station here?
both. See, in these, there are two cases. In the first if statement, it is the ending station. In the second if statement, it's the starting station.
Uh,
Okay. See, here it is written in the second key. Here it is written as the first key. Let me check the options. So, some proc returns true if station is the starting station for the train. No. Some proc will return true when station is the ending station, arrival station. Right. Then only this if statement will be true. So this option is wrong. Let me first evaluate myself, then I'll explain to you again. Then some proc returns false if station is the starting station for the train. If station is the starting station for the train. But then this won't be true. If this is not true, then we cannot come to this statement. B does not
STN,
seem correct.
but for that STN should be the ending station, right? So
Ending
for the
station.
third,
First, it has to be the ending station. So some proc returns true if station is the ending station for train. This is correct. If this statement is true, okay, that means it is the ending station, and we can come to this return true. Some proc returns false if I think this is correct for now. Some proc returns false if station is the ending station for train. Yeah, if it is the ending station, then is it returning false? No. Mm, ending station here. It is very
if it,
confusing because it is the starting station in the first line and the ending station in the fifth, ending station in the third line, starting station in the fifth line. So it
it
will return true if station is the ending station for train. That means this one. Okay.
this
And
would return true only if fifth is true, right? Otherwise, it
yeah,
returns false.
no. How will it return true if fifth is right? If fifth is right, then it will directly return false.
Oh,
No,
I
here.
said, yeah. Okay, yeah. Sixth line
It
returns
will
false. Yes.
return true when 3 is right but 5 is true, false. Line 3 is true but line 5 is false. That means
Yeah,
station is the ending station.
yeah. Okay. Yeah, it
So
cannot be both at
option
the same
C,
time.
no, then it will return false. So it will be true if it is the ending station. It is saying false if station is the ending station. No. Some proc returns true if station is an intermediate station on train's route. Intermediate, can we call it intermediate? So for any C, did it say false or true?
I think this is written in the last statement that if we take this direct of I, comma j, I and j equals 1 and I of k, I and k equals 1 and k of j equals 1, then it returns true. Otherwise, it returns false. So I think here it returns false because it cannot be an intermediate station, right?
I of C, I and K, right? That has to be true. And K
Yeah.
and J, that has to be true.
Yeah, that has to be also true. Yeah.
If these two are true, then we are returning false. But only if I
Yeah.
and K is true, then we are returning true.
Okay.
Okay.
Yeah, okay.
Option E
Yes.
is saying some proc returns true if station is an intermediate station on train's route. This can be true because if it is an intermediate station, then it cannot be the starting station. So this will be wrong. If this is wrong, then we still return true. So option E should also be correct. Let's see F.
Ma'am, this is connected by an and statement, right? So I mean, this could be indirectly.
Which one?
So the next statement, that is the line 5, the statement in line 5. So that would be
Line 5.
connected. Yeah. So that would be connected to line 3 by an and statement, sort of like.
Yeah, this is an in like nested if. If
Yeah.
this
So
outer one is true, then only the inner one is true.
yes.
I mean, if the outer one is true, then only we can check now whether the inner one is true or false.
Yes.
Otherwise, so we won't even enter the if block.
Mhm.
Okay. So F is saying what? That some proc returns false if station is an intermediate station on train's route. No, for intermediate station it won't return false. Some proc returns true if station is not on train's route. Yes, this will return true. Wait, not on train's route at all. That means this outer one, will it return true or false? This outer, if station is not on this train's route, then the entry for train will not be present, and none of this will be executed, and we will directly go to mm, row to station. I think there is a possibility of it being false then. If it is not at all in the train's route, then for no R, this train will be present in the dictionary.
Yeah, the key is itself not present then, right?
Hmm.
Then it should return false.
It should return false. So I think A, I think C, E, and F are correct. Not sure. Oh, there is an H also. So many options. Okay. Some proc returns false if station is not on train's route. Hmm. Some proc will return false if it is not on train route. B, C, F, H. So C, F, H, we were right. So B has to be correct and E has to be wrong. Somehow B is correct. So some proc returns false if station is the starting station for train. If it is the starting, oh, correct, it was right. Yeah, it is the starting station, so it will return false. Correct. B will be correct. And E is wrong. Why? Because some proc returns true if station is an intermediate station on train's route. Okay. So if it is some intermediate station, then are in rows of A, right? We are checking. Intermediate station.
We are actually checking for intermediate station, right?
Yeah. This option I'm not getting. Some proc will return true if station is an intermediate station on train's route. That means not the starting station or the end station. Right. So if it is not starting or end, mm, then this will return false. And this outer if will, this closes here, this closes here. It
Ma'am,
will
this
be,
is true. Then the return statement in line 5, line 6 will return false, right?
see,
If it's
true
a
will only be returned when we reach line 9, right?
yes,
Now,
and
how
this
can we reach 9 considering that station is an intermediate station in the train's route? So if it is an intermediate station, it will never be the starting or ending station, right?
yes.
That means line 5 will be wrong. And actually, you cannot say that line 5 will be wrong because here the keys are arranged according to the station number. So the train can get to station and then from there to C, or it can get to R and then from there to station if these are intermediaries,
Ma'am,
because there are multiple entries for the same train.
just one thing is confusing here is that when we were doing this one hop route thing, so we were having this statement where we would go from I to K, and I to K is 1 and K to J is again 1. So
Hmm.
we are sort of doing the same statement here from 3 to 5, right? So if
Yeah,
this holds true, then it returns false. So which means that
exactly. So,
STN,
so if STN is some intermediate station, right, that we start at
yeah,
R and then go to station and then from station to C. So station is the intermediate station.
yes,
This STN
exactly.
is the intermediate station. In that
Yes,
case, so it should return false then.
false.
But they are saying that it should return true. That's why I'm confused about it. Okay, let's not waste time. Let me check this question by myself. In next session, I'll discuss this question. Okay,
Okay.
won't waste time here. Because I haven't solved the previous question, so might be something I'm missing in dictionary A also. So I have to look through all 4 questions first. So let's solve 6, 7, 8, 9, and this one I will ask whoever takes the next class to solve this once. Okay, question 5. Let's see once what is given in the explanation. Here the procedure is going through each row in matrix and checks whether train is arriving on station STN from station R in line 2. If it is true, then the procedure is going through each columns in matrix A and checks whether the train is departing from station in line 4 to station C. If statement line 4 is also true for any of the columns C, then the procedure returns false. Yeah, so if both of them are true, then procedure returns false. If both conditions in line 2 and 4 are true, then station is an intermediate station for train, like we said. And if the condition in line 4 is false, then the procedure returns true in line 8. So we understood it correctly only, which means station is an ending station for train. Here the condition in line 2 is not satisfied for any of the row procedure. If the condition in line 2 is not satisfied for any of the row, procedure will return false. This means station is either a starting station or station is not on the train's route. So keeping this in mind, how can I explain option A? Sum proc returns false if station is an intermediate station on train's route. Oh, it's correct only, right?
Is it something like hopping?
This is correct. E, why we got E is wrong, that it returns true. Yeah, this I understood now. So if it is an intermediate station, right? Intermediate means that both line 3 and line 5 are correct. As soon as both if statements are correct, it will return false, not true.
Yes,
Correct.
yes.
That's why this one is false. Yeah. Option B, C, F, and H are true. Okay, I'll discuss this once in the end again. Let's first. Yeah,
Yeah,
anyone has any
something like,
question now?
yeah, it's something like hopping idea only, right? Ideology, no?
Yeah, hopping thing only. So station becomes the K here. Okay, so I
Okay.
to K, K to J. Okay, these hard questions are not asked in exams. It takes a lot of time. So yeah, this one. Assume that there are n stations in the train's dataset indexed from 0 to n minus 1. Consider a graph with stations as nodes. So there is an edge from station I to station J. Okay. So every station is again indexed from 0 to n minus 1. We have to consider a graph with stations as nodes. There is an edge from station I to J, if and only if there is a direct train from I to J. Right. So there will be an edge from I to J if there is a direct train from I to J. And the graph is represented by a matrix direct. So like we formed that direct matrix, same thing. So there is an edge from I to J when there is a direct route and 0 otherwise. So assume that direct matrix has already been computed. Station J is reachable from I if we can find a non-empty sequence of trains that take a passenger from I to J. Basically, this is that hopping thing. That means if I to J, right, if I to J is 0 in the direct matrix, that means there is no direct route. But if we can reach J from I using a non-empty sequence of trains, that means by 1 hop, by 2 hop, by some number of hops, if I can reach J from I. Okay. That take a passenger from I to J. In other words, J is reachable from I if there is a non-empty sequence of edges that connect I to J, like in the graph that we made, right? The following pseudocode computes a matrix B of identical dimensions as direct, that is n cross n, same thing, but such that B of ij is 1 if and only if J is reachable from I. All other entries are 0. So that means what? B has to represent what? Everything. Okay, up to n minus 1 hops. If n is the dimension, okay, if n is the dimension of the matrix, then how many hops are possible? N minus 1
Minus
hops.
one.
N minus 1 plus 1.
So it has to increase everything, include everything from direct to 1 hop to 2 hop to 3 hop, 4 hop up to n minus 1 hops. Every information should be reflected in this B matrix. Whenever there is a chance that I can reach from I to J using up to n minus 1 hops. Okay, so what is the code saying? N is length of keys of direct as usual. B is the matrix of n cross n dimension. For each row, R in rows of direct, each C column in columns of direct. First, you copy all the direct entries into the B dictionary, just like we did with that one hop. First we copied the direct, and then in two hops we copied the one hop, like that. First you copy the direct entries in BRC. Okay, B
I
matrix.
mean, one hops will copy the direct, right?
Yeah, and in direct in two hops we'll copy the one hop.
And one,
Okay.
but in two hops will copy the one hop plus the direct as well, right?
Yeah, direct is already then assumed to be inside that one hop dictionary.
Yes,
Okay.
yes. Because okay, that's initialized in the one hop. Okay.
So here we first just take the direct entries and assign them to the B dictionary. Then we assign hops as 0. Okay, we know 0 hops means direct. While hops is less than n minus 1. Okay. So since we can reach up to n minus 1 hops and we are starting from 0. So we can, how long can this go on for? Till n minus 2. Hops can get up to n minus 2. Right? N minus 2 is the smaller number than n minus 1. So once it reaches n minus 1, we will stop this while loop. So hops first starts from 0. Then in B, we call the one more hop procedure with B as the parameter. What is one more hop doing? See.
That will copy
So,
from direct hop to the B.
so first in B, we have already copied all the direct ones, right here.
Yes.
Then here inside the while loop, we are calling one more hop procedure inside this B variable, passing B as the parameter, B dictionary or matrix as the parameter. So in this procedure definition, what it is doing, for each R in rows of B, each column in rows of columns of B, something is happening here. And then whatever it returns, we get it back to B, and then hops is increased by 1. So what is happening in this place?
I think it will connect, the direct, train to the next hop.
Yes, so direct, then one hop, then two hop, like this, it should increment.
Yes.
So it returns, this procedure will return the new B. Okay. So here we can check the examples, options. Pseudocode is incomplete. So we know that B has to store up to n minus 1 hops, right? So first, option A is saying if BRC is equal to 1. So initially we already gave all the direct roots into B, right? So just by checking for each k in columns of B, if I first check that BRC is 1, that means what? A direct root is present, right? Because that
Yes.
was the initial entry of B. So if a direct root is present, we are not checking any further because that entry will remain 1 whether there are more 1 hop roots, 2 hop roots or whatever. If the entry is once assigned as 1, if there is a direct root, then there can be other roots also. But it will never go back to 0. So we can exit the loop at that point. If it is not 1, then there is another if statement. Then you check for an intermediate station, that from R to K there is a root and from K to C there is a root. Then I can say that from R to C there is a root. Right? So this is for the first iteration, B is the direct dictionary only. Right? Now B will become the direct plus one hop dictionary. Correct?
Yeah, yes, ma'am.
So after this is done, then you can exit the loop. Okay. For every K, we have to do this. Wait. If
Option A looks seems
BRK,
correct actually.
yeah, this option seems correct. BRK is 1, BKC is 1, then you assign this as 1, and yeah, so once we find that K, we can exit the loop. And this option is right. Option B is saying you don't check for the direct entry. You directly go and check that if there is such a K for which there is a one hop root. This is also correct, I think. Because whether you check for the direct entry or not, it doesn't matter. If there
Yes.
is a one hop root, then it will automatically detect that here. This should also be correct. C is saying for each K in rows of B. So here we are checking with rows, here we are checking with columns, but remember it doesn't really matter because columns and rows are same values, right? So here also the same thing we are checking. So conceptually this should also be true. B, let's see. For K in columns of B, okay, here this is wrong. Why? Because we can't start from K, right? K has to be the intermediate station. It should be
Yes.
RK, not KR. So this is wrong. So I think the first three options are correct. Yeah, A, B, C are correct. This is clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
this
ma'am.
is simple, just that one hop route thing. Yeah, this is the question I was talking about. See, this is the graph. So you consider this graph for a case of n equals to 5. So there are 5 distinct stations. Matrix B is computed using the above pseudocode. So the last pseudocode we saw, that is how the matrix B is being computed. What is the value of sum after executing the following pseudocode? So you imagine that you already have matrix B now. Okay. So it is saying sum is 0 initially, then for each R in rows of B, each C in columns of B, sum is equal to sum plus B of RC. So what should this sum be?
It will give the half count number actually. 1, 2, 3, 4, 5 will give.
See something here. In this graph, you can reach every node from every other node, correct? Since it's a
Yes.
cyclic graph.
Yes.
The hops don't matter, but you can reach every node from every other node. Okay. That means when, see, in this procedure, when we did the last sum, in this procedure, till when we were running the while loop, till n minus 1 hops, right? That means I will check everything up to n minus 1 hops, where n is 5 here. Now, in that n minus 1 hop, that dictionary, how will the matrix look like? It will be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And since I've calculated for all the hops, and there will be an entry 1 for every 2 stations at some point, right? When we reach that n minus 1th hop, that dictionary, that is this matrix, we must have found a route between every 2 stations using some number of hops, correct? Because they're all connected. That means every entry in this 5 cross 5 dictionary will be what? 1 or 0.
Everyone.
Every entry will be 1. See,
So it will give
0
the
to
sum
1, this
of.
is direct. 0 to 2, this is 1 hop. 0 to 3, this is 2 hop. Like this for every node you can do. So till the time you reach n minus 1 hops, you would have found a route for every station to every station using some number of hops.
Yes.
That means every entry in this matrix will be 1. How many such entries are there? There are 5 stations. So 5 cross 5, 25 entries. Every one of them is 1. So the sum will be 25 only.
Yes, ma'am.
See, the
We
answer
will
is
need for
25.
the.
Is this question not clear for anyone?
Yeah, yeah, yeah. Yes, 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 ma'am. Clear, clear.
Okay. Let's see next question. Okay, 8 and 9 are connected again. So following pseudocode is execute. Okay, this we did in the last class. Remember the trains dictionary, this I wrote in details also, that here every train number is the key and the corresponding value is the list of stations through which it passes. Correct. This is the same trains dictionary. Now in this example, the train with train number 12281 starts from Bhubaneswar, ends at New Delhi via all these stations. So like this, there is an entry for every train number. Common number L1, L2 returns what? Number of common stations between list L1 and L2. That is number of common stations between two trains. Correct. That's what it does. Now you have to observe this pseudocode. So do something is a procedure which takes this train dictionary as your parameter. Okay. I is 0, index is a dictionary. For each T in keys of trains. So what is this part doing?
Giving me the list of trains, right? And
From
the train
line 3,
indices.
from line 3 to line 6, we are just assigning indices to individual trains. Right. See, T from keys of trains, that means T is nothing but a train number and I is the index. So in index dictionary, entries look like this. So 12259 is a train which has 0 as index. 12281 is a train which has 1 as index, like this. Correct?
Yes, ma'am.
N is what? Length of keys of index. So whatever the number of unique trains is, that is the length of N. That is N. Okay, that is the length of keys of index is N. C station is what? Another matrix we are creating with n cross n dimensions. For each T1 in keys of train, that is some train number, and each T2 in keys of train, that is some other train. If T1 and T2 are not the same train, then what are we checking? See, C station is the matrix. Okay, not checking anything, we are assigning. C station is the matrix. What are the ij values? I value is index of T1. Let's take these two stations for example, these two trains for example, 12259, 12281. This is T1, this is T2. Okay. So T1 and T2 are different train numbers. What is the index of T1? 0. So C station, row is 0 in the C station matrix and column is 1 coming from T1 and T2. What are you assigning this cell in the matrix? Common number of stations between trains T1 and T2. So the list of stations like this, for every train there is a list of stations like this given, right? So for T1 and T2 you're checking how many common stations they have. Okay, and that number of common stations will be assigned to this 01 index in the C station dictionary. Let's say they have 3 common stations. So C station matrix for 0th row, 1th column, it will be, the value will be stored as 3. That's what it's doing. And it is returning this new matrix and the index matrix, index dictionary.
And
Is
this
the code
com
clear?
number, yeah, this com procedure will return the common trains, the number of common trains between the
Number of
station
common
or
stations.
list of no common stations.
Number of common, see, common number L1, L2 returns the number of common elements between L1 and L2.
Okay.
So list L1 here is what? Trains of T1, which stores the list of stations through which train T1 goes. And trains of T2 stores list of stations through which train T2 goes. So among these two lists, how many elements are in common? That will be given by this procedure. Got it? So this is what this code is doing. Now let's see the question. If C station ij is 0 for some I and j where I is not equal to j, then which of the following statement can be concluded? So when will it be 0? When there are nothing in common, no stations are in common.
Yes.
Correct. So which option? There is no route between stations with indices ij using one hop, no. No common trains, no. There are no common stations on the routes of trains with indices I and j. This is correct. Two different trains with no common stations. C, yeah, C is the answer. And there is one more related question, this one. So assume we start our journey using a given train T. Now consider the following procedures. They should return true when it has at least one common station with all other trains. So let's say I have taken this train 12259. Okay. So we start our journey using this train. Now we have two procedures given here. The goal of both procedures is same, that they should return true when this particular train has a common station with all other trains in the data set. Okay, only then these two procedures should return true. So these are doing the same thing written in two different ways. So let's check the procedures, which one is true, or if both are true or none of them are true. None of them are correct. So first is train boarding 1. It is taking the train number and the train's dictionary as the arguments. So for us, let's train number be 12259. So you construct this CMAT and index from this do something procedure that we did earlier. So CMAT is nothing but this one, C station. Okay, see this is returning C station and index, the do something procedure. So these two dictionaries only, matrix and dictionary, we are creating in the beginning. Okay, index is what? Index is a dictionary that has train numbers as keys and the values are the corresponding index numbers for the trains. CMAT is a matrix where for every ij value, where I indicates the train index, j indicates the train index, the corresponding value represents what in that cell, whatever value is present represents how many common stations are there between these two trains. Okay. Now K is storing index of T, that means index of 12259. Let's say the index of this train in our data set is 1. Okay. So for each I in columns of C matrix, so we are now going through the columns of this C matrix. If I is not equal to K, okay, That means I is some other train, not 12259. So our goal is to check that this 12259 train has at least one station in common with all other trains. So that's why we are going through all the i's in columns of C matrix. So if I is not equal to k and the C matrix entry for k comma I, that is kth row and ith column, is 0, then return false. If this is 0, then it means what? That there are no common stations between trains I and k, right?
Yes.
So if there are no common stations, then it has to return false, because our goal is what? There should be one common station with every other train. Now, if this condition is never true, that means for any k, for any I that is not equal to k, C matrix ki is always something other than 0. That means there is something in common. Then only this procedure will return true. So is this procedure meeting our goals or criteria?
No.
Yes, ma'am.
Yes. So this is correct. Now let's take the second procedure, what this is doing. So again, same thing is taken as your parameter, the train number and the trains dictionary. Now count is a variable here, which is initialized as 0 for each T2 in keys of trains. Okay. If T2 means what? Some train number from keys of trains. If common number, what are we comparing? The train that we are going through, that is 12259, and the particular train in the for loop iteration. If these two have something in common, that will be displayed by this procedure. If it is greater than 0, that means they have something in common. Then count will be updated or incremented by 1. Okay, so this thing will check T against every other station, every other train in the trains data set, and count will be updated likewise. So if the train 12259 has common stations with every other train, then value of count should be what at the end? It should be equal to the number of trains in the data set, right? When is count getting updated? When there are common stations, at least one common station between two trains, T and some other train. So if T has common stations with every other train, then count will be updated that many times, right? As the number of trains.
Yes, so
So
the
if,
number of times T appears in common with T2, right? So
yes, and
yes,
our goal is that T should have common with every train, right? Every train in the trains data set or the trains dictionary. So if this is a correct procedure, that means if T has common stations with every other train, then count will be incremented that many times, as many as there are trains in the trains data set, right? So that's why in line 8 we are checking that if count is equal to length of keys of trains, then we return true. If it is less, that means there is at least one or two such trains which don't have anything in common with our train. So is this procedure correct?
yes.
So that seems like both are correct. I think both are correct. Yeah, both are correct. Okay, that's the last question. So I hope everything is clear in this practice assignment. If please go through this everything we learned today by yourself, because it's a lot of information, right? So just go through this by yourself. Whatever doubts arise, you again ask them in the Monday session. That will also be on week 10. Okay.
Thank you.
All right. Yeah. Thanks for joining.
Yeah, ma'am. This practice assignment, answer sheets, I mean, it is kind of explanation. Where do we get that? Is it a part of the dashboard?
This solution sheet.
Yeah, yes, ma'am. For all the weeks.
Okay. Are they not uploaded?
I don't know, ma'am, where to check actually. I'm just trying
In
to.
the supplementary content you should find, or in the practice solution, it is present in every week only.
Oh, okay.
Okay, there it is given. If it is not given, you let the instructor know in the next class, we will upload it.
Yeah, yes, ma'am. It is there only for till week 3, ma'am. not for all weeks.
Okay, okay. After that, if it's not uploaded, I'll upload them. Okay.
But it's almost, we are at 10th week, but still I could see only the till week 3, ma'am.
So week 3 is the last assignment or solution that is given.
No, in the supplementary content, I could see only the graded assignment solution. Point number one, I don't see that, I don't find that practice assignment solutions.
Okay, okay. Let me check the portal once. I'll upload whatever is not there.
Yeah, please, please, so that it will be
Okay.
helpful for us
Yeah.
to know, to understand that.
In the
Yeah, yeah. Okay.
portal, we have the PDF of the questions, but not the PDF of the solutions.
Yeah, yeah. Okay. I'll upload them or I'll ask you sir to upload. Okay.
Yeah,
Okay,
ma'am.
thank you.
Till, I mean, both, graded assignment.
Yeah, yeah.
So
Both graded and
we
practice.
completed and
Till
then
week,
practice assignment. Till
yeah,
week,
till week
10,
9, I will update all the graded ones also, and till week 10, I'll upload all the practice ones. Okay. Once
yeah,
the
please.
assign date is gone for graded in week 10, then we'll upload the graded solution.
Yeah, please, ma'am, please, ma'am. Yeah.
Yeah. Okay. All right. Yeah. Thanks, everyone. Good night.
Thank you.